The moon is not what you think it is. For more than 50 years, since the last Apollo astronaut left its surface in 1972, we told ourselves we understood it. A dead world, a gray companion, silent, stable, fully mapped. But on April 6th, 2026, 4 astronauts aboard the Orion spacecraft passed behind the moon. And for 40 minutes, no one on Earth knew if they were alive. They crossed into the far side, the half that never faces Earth, a place no human had ever truly seen with their own eyes in real time. And what they saw there began to fracture everything we thought we knew, not over decades, but in a matter of hours. Their names are Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, the crew of Artemis II, the first mission in history to send a woman, a black astronaut, and a non-American beyond low Earth orbit. They launched from Kennedy Space Center at 6:35 in the evening on April 1st, riding the most powerful rocket NASA has ever built, the Space Launch System, 322 feet tall and generating 8.8 million pounds of thrust at liftoff, enough to leave Earth orbit in less than 5 minutes. And once that burn was complete, there was no turning back. The path they followed is called a free return trajectory, and it exists for one reason: because failure is expected. Even if the spacecraft's engine had completely failed, the moon's gravity would have taken over, slinging them around and sending them back toward Earth. Apollo 13 followed the same path in 1970, not as a plan, but as a last resort. That is still the safest way to reach the moon, which tells you something important. The safest plan is the one that assumes everything could go wrong. As Orion slipped behind the moon at roughly 467 miles above its surface, every signal vanished. No communication, no telemetry, no commands from Earth. Just 4 people inside a capsule the size of a van, cut off from the entire planet. For 40 minutes, they were the most isolated humans who have ever existed. For 40 minutes, the moon itself blocked every radio signal between their spacecraft and Earth. No voice from Houston, no telemetry, no abort commands, nothing but silence. And the oldest, most battered landscape in the solar system stretching out beneath them. Victor Glover, the mission's pilot, tried to describe what he was seeing in real time before the blackout. Oh, he couldn't, not really. His exact words, transmitted moments before the signal vanished, were that humans have probably not evolved to see what they were seeing. That it was almost impossible to describe. And when the signal cut out at 6:44 in the evening, Eastern Time, the 4 of them were left alone with it. No confirmation, no explanation, just the moon. So what did they see? To understand why the far side of the moon feels so unsettling, you first need to understand how different it is from the side we see every night. The near side, the one that always faces Earth, is covered in vast, dark plains known as Maria. Ancient lava flows that flooded enormous impact basins and cooled into flat basalt seas billions of years ago. About 31% of the near side is covered in this volcanic rock, giving the moon its familiar face, the one humanity has drawn, photographed, and recognized for centuries. It looks calm, almost predictable. The far side is the opposite. Almost none of those smooth plains exist there, less than 1%. Instead, it is a wall of craters, layered on top of craters, stacked over even older impacts, It looks less like a world and more like a surface that has been under continuous attack for 4 billion years. The crust there is roughly 50 kilometers thicker than on the near side, and no one fully agrees on why. The leading theory points to a cataclysmic impact near the lunar South Pole, violent enough to send a wave of heat through the moon's interior, redistributing radioactive elements and rare materials toward the near side. That single event left behind the largest preserved impact structure in the entire solar system, the South Pole Aitken Basin. It stretches roughly 2,500 kilometers across and plunges as deep as 13 kilometers. If you placed it over the United States, it would swallow everything from Texas to Virginia. The mountains along its rim rise among the highest on the moon, reaching elevations of around 8,500 meters. But what matters most is not what you can see. It is what lies beneath. Because buried under that basin, something enormous is still there. In 2019, a team led by planetary geophysicist Peter James at Baylor University combined gravity data from NASA's GRAIL mission with topographic measurements from the Lunar Reconnaissance Orbiter. What they found was not just unusual, it was deeply unsettling. A mass anomaly, buried at least 300 kilometers beneath the floor of the basin, a dense structure weighing at minimum 2.18 quintillion kilograms. James described it as the equivalent of burying a mass of metal 5 times larger than the big island of Hawaii beneath the surface. Whatever it is heavy enough to pull the basin floor downward by more than half a mile, as if gravity itself is slightly distorted there. The most likely explanation is that it is the metallic core of the asteroid that created the basin in the first place, still embedded in the moon's mantle after 4 billion years, like a fragment of a bullet that the body was never able to expel. Still there, still pulling, still changing the structure around it. The Artemis II crew became the first humans to see the eastern edge of this basin with their own eyes, not through robotic cameras, not through processed data, but directly through the windows of their spacecraft, a view no human had ever experienced before. The Apollo astronauts never saw it. Their flight paths never crossed the right regions, and the lighting conditions were never aligned. Artemis II was different by design, sweeping across the far side at an angle and distance that exposed roughly 21% of it to direct sunlight from the crew's perspective, enough to reveal features that had never been seen firsthand by any human being. One of the key observation targets was the Orion Basin, a massive impact structure nearly 600 kilometers wide, sitting at the boundary between the near and far sides. From orbit, it looks like a perfect bullseye, a frozen shock wave from an impact that happened 3.8 billion years ago. The crew had trained for months in Iceland and other volcanic landscapes, learning how to recognize and describe geological features in real time. They are not scientists by profession. They are pilots and engineers, trained to observe, to report, to stay precise under pressure. But what they were seeing was pushing even that training to its limits. Christina Koch noted that the smaller, more recent impact craters appeared shockingly bright against the ancient surface around them. She compared them to tiny pinprick holes in a lampshade, glowing white against the dull gray terrain. Not just brighter, but almost unnatural in contrast, as if they didn't belong to the same surface. Before even reaching the far side, the crew passed over one of the moon's most puzzling features, Reiner Gamma. A bright swirling pattern spread across the surface like a brush stroke of white paint dragged across dark rock. It has no elevation. It is not a crater, not a volcanic formation. It is just there, flat, visible, and unexplained. What makes it even stranger is what lies beneath. The pattern aligns perfectly with a localized magnetic anomaly in the crust. The moon does not have a global magnetic field. It hasn't had one for billions of years. And yet, isolated patches of magnetized rock still remain, scattered like fragments of something that once protected it. Reiner Gamma sits directly above one of these patches. Scientists still do not fully understand whether the magnetism is shielding the surface from solar wind, or if some other process is responsible for creating that bright swirl. The Artemis II science team marked it as a priority target, and the crew captured images as they swept past. As they moved deeper along the far side, Victor Glover became fixated on the terminator, the shifting boundary between light and darkness. Along that line, the surface transforms. Sunlight strikes crater rims at extreme angles. Casting shadows to deep, they appear bottomless, not like shadows, but like openings. He described it as full of magic, islands of light floating over valleys of darkness, places that looked like you could fall straight through to the moon's core. A landscape that does not behave the way your brain expects it to. At the same time, Christina Koch and Jeremy Hansen were photographing the Vavilov crater, sitting along the rim of the much larger and older Hertz-sprung basin deep on the far side. Back in Houston, the science team was updating their observation plan in real time, adjusting targets based on what the crew was seeing and reporting moment by moment. The crew also noticed something more subtle, but just as important: color. Variations across the surface that no orbiter image had ever fully captured. Shades of brown and green across the near side. Faint blue tones in certain regions. Differences so slight that cameras tend to flatten them, but human eyes can still detect. These color shifts are not cosmetic. They carry information, revealing mineral composition, surface chemistry, and the relative age of different regions. In other words, they are clues, subtle but critical, to the moon's geological history. And that realization leads somewhere uncomfortable, because in 2023, researchers detected something beneath the far side that should not be there. A thermal anomaly buried under the surface, roughly 50 kilometers wide and about 10 degrees Celsius warmer than everything around it. The most likely explanation is a massive block of granite buried deep beneath the surface. On Earth, granite is common, but on the moon, it should not exist at all, because granite requires water and plate tectonics to form, processes the moon does not have. Researchers believe it may be the remnant of an ancient volcano, one that went dormant 3.5 billion years ago, but whose residual magma is still releasing faint heat even now, not active, but not entirely cold either. Lead scientist Matt Siegler noted that the finding looks far more like what we see on Earth than anything expected on the Moon, and it raises a question no one thought they would be asking. If something is still warm under the surface, what else might still be there? Then there are the lava tubes. Radar data and high-resolution imagery suggest vast underground tunnel systems carved by ancient lava flows. Entrance pits visible from orbit may lead to caverns large enough to shelter entire structures, entire habitats, entire missions. But their true size, distribution, and stability remain unknown. What is inside them is even less certain. Trapped gases, untouched volcanic material, environments completely different from the surface. All of it remains speculation. For now, they are sealed, waiting, and then the crew witnessed something no human had ever seen from this perspective: a total solar eclipse. Not from Earth, but from lunar orbit. As Orion moved behind the Moon, the sun slipped out of view, disappearing completely behind the lunar disk. For nearly 54 minutes, totality remained, far longer than any eclipse visible from Earth. The sun's corona expanded outward in a brilliant halo, bright enough, as Victor Glover described, to trace the entire outline of the Moon in light. Jeremy Hansen reported that during totality, the sun was illuminating the entire edge of the Moon, outlining its surface in a ring of light. Ridges and peaks stood in silhouette against the burning white glow of the sun's outer atmosphere, a horizon defined not by darkness, but by fire. But then, something else appeared. Hansen and Reed Wiseman both reported seeing brief flashes on the surface below. Not reflections, not camera artifacts, but sudden, isolated bursts of light, moments that appeared and vanished almost instantly. The most likely explanation is micrometeorite impacts, small objects striking the far side at extreme speeds, releasing flashes of energy as they hit. The Moon has no atmosphere to burn them up, no magnetic field to deflect them, nothing to protect its surface from direct exposure to space. Scientists listening in Houston asked for more detail. Both astronauts confirmed seeing at least one flash, but neither could say how long it lasted. There was no time to measure, no way to verify, just a moment that may have been real or something we still do not fully understand. For centuries, observers on Earth have reported similar flashes on the lunar surface. Brief luminous events that appear and disappear before confirmation is possible. Some are likely impacts, others may be electrostatic dust clouds, or gases escaping from beneath the surface. The truth is, we still do not know. What matters is this: every micrometeorite, every particle of solar wind, every burst of galactic, cosmic radiation strikes the far side directly. Nothing slows it down. Nothing absorbs it. The surface is constantly exposed to the full violence of space. And that exposure does not just affect the surface. Apollo astronauts reported seeing flashes of light behind their closed eyelids, caused by high-energy particles passing directly through their eyes. Not reflections, but radiation interacting with the human body itself. Those missions lasted only days. Some astronauts later developed cataracts at unusually high rates. Most lived long lives, with no clear signs of radiation-related cancer. But the sample size is small. Exactly 24 humans have ever left the protection of Earth's magnetic field. That is not enough to draw conclusions. The Artemis II crew is spending 10 days in deep space during solar maximum, the peak of the sun's 11-year activity cycle, when the risk of solar particle events is at its highest. A powerful solar storm can raise radiation levels to near lethal doses in a matter of hours. The Orion capsule provides shielding more advanced than anything Apollo ever had, but it is not absolute. Galactic cosmic rays, born from supernova explosions and other extreme events, travel at nearly the speed of light and can pass through almost any material we have built. Alexandra Stankovic, founding director of the Center for Space Medicine Research at Massachusetts General Hospital, has described deep space radiation as the single greatest limitation on human exploration. In her words, the showstopper. Researchers are testing everything they can: experimental drugs, nutritional countermeasures, even early-stage gene therapy inspired by radiation-resistant organisms. Because if humans are going to survive beyond Earth's magnetic shield for months at a time, engineering alone will not be enough. Biology has to adapt. On board Artemis II, the Avatar payload carries bone marrow cells derived from the crew's own blood. After the mission, scientists will analyze how those cells responded to the deep space radiation environment. That data may matter more than any image they captured. Because during the blackout, the crew was completely on their own. If a solar particle event had occurred in those 40 minutes, mission control would not have known until it was over. There would have been no warning, no intervention. They trained for this. They had procedures. Orion could maintain pressure, pump oxygen, support life even in an emergency. They wore pressurized suits, but none of that changes what those 40 minutes actually were. 4 people sealed inside a capsule the size of a van, separated from Earth by more than 2,000 miles of solid lunar rock, surrounded by a landscape shaped by ancient violence, exposed to radiation that the human body was never designed to survive. When the signal returned, mission control in Houston erupted. The silence was broken, and with it came something no one on Earth had ever seen before. The crew reported watching Earth set behind the lunar horizon, a pale blue crescent slowly sinking behind gray. Cratered rock, not rising, like the iconic image from Apollo 8, but falling away. NASA later released the image, calling it Earthset, a reflection of the famous Earthrise photograph taken by Bill Anders in 1968. But this time, the meaning was reversed. Earth was not appearing. It was disappearing. Christina Koch described the moment in a way that cut through the technical language of the mission. She said that when you see Earth from that perspective, you realize how much we share, how everything we need is already there, and that you cannot fully understand that until you have seen it from somewhere else. During the flyby, the crew named 2 craters, one they called Integrity, after their nickname for the Orion spacecraft. The other they named Carol, in memory of Reed Wiseman's late wife. It lies along the boundary between the near and far sides of the moon, a small but permanent mark, visible from Earth if you know where to look. Hansen described it simply as a bright point on the moon. But that point now carries a human story, embedded into a landscape that existed billions of years before us. Artemis II also set a record, the farthest distance any human has ever traveled from Earth. reaching more than 252,000 miles. Orion passed the moon at tens of thousands of miles per hour, completing its primary observation window in just 7 hours. During that time, the crew captured thousands of images, most of which have not yet been transmitted back to Earth due to bandwidth limitations, but those images will matter, not just as records, but as data that could reshape how we understand the moon and where we choose to go next. Because this mission was never just about seeing, it was about learning where humans can survive. Future Artemis missions will attempt landings, and the crew's observations of terrain, shadows, and surface detail will directly influence those decisions. A surface that appears flat from orbit can become unpredictable when viewed by human eyes. Along the terminator, shadows behave differently, pooling in ways that can hide hazards that no camera can fully reveal. What looks safe from a distance may not be safe at all. The far side of the moon is already contested territory. Not politically. Not yet. But scientifically. In 2019, China's Chang'e 4 lander touched down inside Von Karman crater, a 186-kilometer wide basin within the South Pole Aitken region. It was the first successful soft landing on the far side in human history. But even that required a workaround, because direct communication with Earth is impossible. From the far side, a relay satellite had to be placed in a halo orbit beyond the moon, maintaining a constant link between the lander and Earth. Even reaching the surface, there requires infrastructure we are still learning to build. The rover confirmed something critical: minerals like olivine and pyroxene, materials from the moon's mantle, exposed by an impact powerful enough to excavate rock from hundreds of kilometers below the surface. Evidence that the basin is not just a scar, but a window into the moon's interior. In 2024, China's Chang'e 6 mission went even further, collecting samples from the far side and returning them to Earth. For the first time, the material from the moon's hidden hemisphere became available for direct laboratory analysis. Scientists are still studying those samples, but the far side offers something else. Something no other place in the inner solar system can provide: silence, true radio silence. Every signal from Earth, every broadcast, every network, every transmission is blocked by thousands of kilometers of solid rock. For radio astronomers, this makes the far side the quietest listening point imaginable. A place where interference disappears. Telescopes placed there could detect frequencies below 30 megahertz, signals that Earth's own atmosphere blocks. A window into the early universe, into cosmic events we have never been able to observe directly. Multiple space agencies are already considering observatories on the far side for this reason, because the moon is not just hiding secrets. It is offering us a way to see further than we ever have. For centuries, we looked at the moon and believed we understood it. We landed there 6 times, collected samples from carefully chosen locations, all on the near side. And from that limited data, we built a model of an entire world. That is like landing in the Sahara Desert and concluding that the entire Earth is made of sand. The far side is where the real story begins. A landscape so ancient and so violently shaped that it preserves impacts the near side erased billions of years ago under layers of lava. A basin so large it may have shifted the moon on its axis. A buried metallic mass deep enough to distort the local gravity field heat where there should be none, caverns that remain sealed, a crust so different that it challenges how we think worlds are formed. When Orion cleared the far side and Earth came back into view, Victor Glover said something simple. The moon is not just something that passes through the sky. It is a real place. And the more we learn about it, the less comfortable that reality becomes. Because the far side is not just different, it is different in ways that keep forcing us to rewrite the story. The granite that should not exist, the mass that does not match any model, the asymmetry no single theory can explain, magnetic remnants left behind in a crust that lost its field billions of years ago. Even the moon itself may not be as still as we once believed. Seismic data from Apollo revealed shallow moonquakes, subtle movements beneath the surface, suggesting that something inside is still shifting. Not alive, but not entirely silent either. Every answer the far side gives us leads to more questions, and the questions are becoming harder to ignore. The Artemis II crew is on their way home now, returning to Earth after traveling farther than any human before them. When they return, they will carry something more than data, not just images or measurements, but a direct human experience of a place seen we thought we understood. A version of the moon that was not filtered through instruments or models, but seen with human eyes. The same place that made Victor Glover, a test pilot and astronaut who has spent months in orbit, say that what he was seeing was beyond what humans have evolved to perceive. The moon has not changed. We have, and for the first time in half a century, we are seeing it again. Not as a symbol, not as an image, but as it actually is. And the more clearly we see it, the more uncertain the story becomes, because we are only just beginning to understand what has been there all along. If this journey changed the way you see the moon, then you are exactly where you need to be. There is so much more we are only beginning to understand. Subscribe and stay with us as we keep exploring the places that challenge everything we thought we knew.